Okay, so let me look at problem number 5. We have carbon monoxide is combined with hydrogen to form methanol at 5.25 times 10 to the 6 Pascal and 250 degrees Celsius. We need to make sure this is balanced. There are 4 hydrogens on this side. I think that works to balance it. They tell us that we have 450 milliliters of carbon monoxide and 800 milliliters of hydrogen. And they want to know what the limiting reagent is. Okay, so we can now go and figure out what the moles are by using PV equals nRT. And we are going to need the moles, but I'm going to show you a little trick after we do this. Okay, so the number of moles of carbon monoxide is PV over RT. By the way, to change pascals to atmospheres, we're going to need to divide by 101.325 pascals per atmosphere. So that's going to be 51.8 atmospheres. That's a lot of atmospheres. So we've got 51.8 atmosphere times 450 milliliters, or 0.50 liters, divided by R, divided by temperature. It's 250 plus 273.15. So 51.8 times 0.45 divided by 0.0821 divided by the sum of 250 and 273.15 gives me 0.543 moles. So that's 0.543 moles. And then how many moles of hydrogen is the pressure of all of these? So we have pressure again of 51.8 atmosphere, 0.800 liters, divided by R, 0.0821 liters atmosphere per k mole, times temperature of, what's 250 plus 273? 523.15. So we plug all these in, 51.8 times 0.8 divided by 0.0821 divided by 523.15, and that gives me 0.965 moles. So which one's my limiting reagent? Remember, we divide by the coefficient to figure that out. 0.53 divided by 0.53 is obviously 0.53. 0.965 divided by 2 is 0.482. So it's actually hydrogen that's my limiting reagent. Okay? So we're gonna get rid of this. We're gonna have extra carbon monoxide, but we have 0.965 moles of hydrogen. Looking at these molar ratios, I know that I need half as much hydrogen as carbon monoxide. Can you guys just keep it down a little bit? So 0.965 divided by 2 means that we have 0.4825 moles of carbon monoxide. And this is also a 1-to-1 ratio here, so we're going to need 0.4825, or we're going to make 0.4825 moles of methanol. So let's see what the problem asks now that we don't know how many moles we're dealing with. We know what a limiting reagent is. We know then that carbon monoxide is in excess. Volume and mass of methanol will be produced. Well, we know we have this amount of methanol produced, okay? And we also know that it is a 2-to-1 ratio. So if I use 800 milliliters of hydrogen, only half that much is going to be produced of methanol, right there. So that's the answer for the volume of methanol produced. And as far as molar mass, as far as grams, excuse me, let's go down here. How many grams of methanol is equal to 0.4825 moles of methanol. I'm going to cancel it out by moles of methanol. Oops, OH. The molar mass is, let's see, it's 12.01 plus 4 times 1.008 plus 16, 32.042. So the mass of 1 mole is 32.042 grams. We have 0.4825 moles, and we get 15.5 grams. The problem then continues to ask us, if the percent yield of 90 is 90%, how much of that is actually produced? Well, what's 90% of 15.5 grams? I'm going to multiply this number by 0.9, and I'm actually going to produce 13.9 grams. And I think that's that problem.